ladies and gentlemen, we are starting, excuse me, there's no more talking. We are starting, it says solving systems of linear inequalities, but that's not what we're doing. That was a typo on my part. We are doing exponents and rules of exponents today. So we're going to pay attention to this. We've got a couple special rules for exponents.
You guys, hopefully this is a clean slate. It's something kind of totally different. Pay attention. Hope to learn along with it.
Okay, so we're looking at the first property of exponents. Rakisha, can you turn around, please? Face front while I'm going over this. Thanks. Okay, so our first one is we've got a to the nth to the nth. So that a times n times n. So let's do an example. If we've got 2 to the third squared, you just simply multiply your exponents. 3 times 2 gives us 6. So this is 2 to the 6. Okay, so that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which gives us 64. So 2 to the 6th is the same thing as 64. Now we could rewrite this out so you could see how this looks. If we have 2 cubed twice, that's 2 cubed and 2 cubed. That's also written as you've got 3 2's and you've got 3 2's. So we have 6 2's, or 2 to the 6th.
You see that?
Now remember, it's not 2 times 3 or 2 times 6. It's 2 times itself 6 times.
So you can take your calculator and, like she said, you would go 2 times 6, but you can go 2 to do.
Right, and you put in your calculator, if you want to do this in your calculator, you put 2, and then you put this little caret symbol that's in your calculator, 6, and it'll do this all for you.
Do all of them have that little caret? Remember how we had 2 separate calculators?
Yep. Okay, so we're moving on to x to the 7th 3 times. Now this is when you have to make sure you use that rule. We've got x to the 7th 3 times, so 7 times 3 gives us 21. So we have x to the 21. Okay? It's just using that special rule that if it's an exponent taken to another exponent, you multiply. Now we're going to look at a different rule. We've got 5 cubed times 5 to the 6th. So I'm going to write out all the 5s there are, and we're going to count how many we've got. We've got 3 here, and then we've got 6 for this one. Now, how many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So what do you think our rule is with exponents? If we don't want to write them all out, what do you think we're going to do? I wrote 5 out 3 times, and I wrote 5 out 6 times, and then how many times I'm timesing 5 by itself? That became my exponent for 9.
We used a total.
So what is my rule if I don't want to write them out? What did I do to those 2 exponents?
I heard it.
What? Added them.
As long as you have the same base. The base is the large number. See how it's 5 to the 3rd times 5 to the 6th? That's 5 is your base. As long as your bases are the same, you add your exponents when you're multiplying. Okay?
So are my bases the same for number 4? We've got x all the way across? Okay, so my base is x, so I keep x the same. Now, how many of the exponents do I have? I've got 3, 2, and 4. So that's going to make, I heard it, say it louder. 3, 4, 5, 6, 7, 8, 9.
Right. We didn't hear whoever did it.
Okay, ladies and gentlemen, let's look. So we've had 2 rules so far, and I've left them kind of up here on the whiteboard. X to the 3rd squared equals x to the 6th. X to the 3rd times x squared equals x to the 5th. So when you see parentheses around them and it's taken to another power, you know you multiply the exponents. When you've got 2 numbers multiplied, 2 bases multiplied together that are the same base with exponents, you add them.
So no parentheses, you're adding.
That's not always true.
Okay.
Because sometimes you'll see x to the 3rd in parentheses. If it's a power taken up to itself, you multiply. Okay? If it's 2 things being multiplied together that has the same base, you add their exponents.
Please add that in your notes, guys. You need to have this down.
Okay, property property of exponents, power of a product. So if we have two numbers multiplied together, taken to an exponent, if each one is taken to the exponent, a to the m, b to the m. So let's do an example of that. If we've got negative 2x squared taken to the fifth, it's negative 2 to the fifth x squared to the fifth. Okay? What is 2 times 2 times 2 times 2 times 2? Let's do that together. 2 times 2 is? 4. Times 2 is? 8. Times 2 is? 16. Times 2 is? 32. Now, Miss Kellerman told you this before earlier in the year. If you've got an odd exponent and you've got a negative number, it's going to turn out negative. If you've got an even exponent and you're dealing with a negative, you're going to end up with an even. But you could also do it this way. A negative times a negative is a positive, times a negative is a positive. Okay, a negative times a negative is a positive, times a negative is a negative, times a negative is a positive, times a negative gives you a negative. Okay? But if you just remember that little rule, it's much easier.
You guys know odds and evens, right?
Yes. 2, 4, 6, 8 is even. X squared to the fifth is going to give you what? X to the 10th. Good, from that other rule. Okay, let's try another one. We've got 5 times x times y to the 7th, all raised to the third power. So I'm going to break this up. I'm going to have 3 different things. I'm going to have 5 to the third power, x to the third power, y to the 7th to the third power. 5 times 5 times 5, you can just put that in your calculator, or 5 caret 3, and you get 125. X to the third stays the same. Y to the 7th to the third, you should have y to the what? 21st. We multiply them together. Good. Is this rule starting to make sense? Well, let's try some more then. Okay. I've got negative 8 times 2x to the third, and 2x to the third is raised to the 2, is squared. So I'm going to leave that negative 8 on the outside, and I'm going to do inside the parentheses first. So I've got 2 squared, x to the third squared. Do you see how it's kind of like the distributive property? I'm taking that squared and I'm squaring every single thing inside the parentheses. Kind of like the distributive property. So now I'm going to get negative 8 times 4, and x to the third squared gives me x to the 6th. And then I simply multiply 4 times negative 8, and I get negative 32 x to the 6th. Okay, somebody want to try this one? You want to raise your hand and tell me what we do for here? Nobody feels that confident yet?
Just try it.
Safaria, you want to try?
Yeah.
Okay, I take 4 to the what?
Third. Then x to the 2.
X squared 2, and then the whole thing to the third power. And then we've got x to the 5th. 4 times 4 is what, Safaria?
16.
Times 4.
32.
Not 16 times 2, 16 times 4. So 4 times 6 is 24. 4 times 1 is 4, 5, 6. So we should get 64. Okay, x squared to the third. What am I going to do? Am I adding or multiplying those? So I get x to the 6th. And then I've got it times x to the 5th. Okay, so x to the 6th and x to the 5th is?
Which one do you do?
You add it, good.
The same base, yeah?
Yep, 64 x to the 11th. That was really good. And see how she stopped herself? She was like, what do I do next? Do I multiply it or do I add it? And then she looked at her rules. So the third rule is up here. 4x squared to the third power, you know we have to take 4 to the third power and x squared to the third power. Kind of like the distributive property. All right, Miss Kellerman, was there any from the homework that we should go over that we didn't really cover?